Okay, so the first thing, let's get started with optimization because that's probably the harder topic. Whatever I write down, I recommend you write down. Obviously, please have something to write with and write on. If you have any questions, don't be afraid to call out. I really don't care. Okay, so with optimization, the first thing we're going to look at is kind of the basic case, which is some kind of field being enclosed by a fence. But I'm going to give a kind of a tougher version of the standard question because I will have a fence like this, and I'm going to have it partitioned twice into three equal areas. I'm going to say the total length of my field is length L, the total width of my field is width W, and I'm going to say that I have, let's say, 400 feet of fence. Now what I want to know is what should my dimensions be? What should my dimensions be to maximize the area? Give you guys a second to write that down. But in general here, whenever we have optimization, we want to maximize or minimize a quantity given some sort of constraint. In this case, the constraint is 400 feet of fence, and we want to maximize the area. So for that reason, if I'm not given a picture, I like to draw a picture first, but since I gave a picture, it doesn't matter. The real first step of optimization is to write down the objective and the constraint equations. Objective and the constraint. You can start with either one. I like starting with constraint because it's always the number. The number here is 400 feet of fence, so that's 400. If I were to ask myself, okay, well, what is that? Is that perimeter or is it area? I would say it's perimeter because when I talk about the fence itself, and it's especially units of feet, that's a length. Units of length is perimeter. If it was area, it would say something along the lines of feet squared. So I know for a fact that this is the perimeter of my fence. The only problem is if I ask myself what's the perimeter of my fence, it's not so straightforward. It's not 2L plus 2W because I have these additional partitions in the middle here. So what I want to say is this. I know quite a few of my lengths. I know the length up here is also L. I know the width over here is also W. And then in the middle, I think we'd all agree that there's width W there and width W there. In other words, a total of 4 widths and 2 lengths. So I'm going to say my constraint, which is perimeter P, I'm going to say that equals 4W plus 2L. Any questions so far? So just to be frank, a lot of my students have trouble coming up with equations for perimeter and area. If you think you're good on it, great. But I'm just telling you right now, a lot of my students have trouble with these kinds of questions. The best recommendation I can give is to really just look at as many different scenarios as possible. You can find them online on YouTube, online just in a Google search. Plenty of places to find examples, your homework, whatever. Just make sure you're seeing as many examples as possible so there's no surprises when the quiz or the test comes. Now for the objective is going to be area, and I know that right away for two reasons. Number one, perimeter goes hand in hand with area. If my constraint was perimeter, then almost certainly my objective is area. And also because notice I want to maximize the area, and that's a dead giveaway that objective is area. So now I need to come up with the area of my field. It looks kind of complicated with all the different things, but just imagine I have a rectangle. It doesn't matter about the partitions for area because it's just the whole thing. And the area of my red rectangle I just drew in here, it's just going to be the length times the width, L times W. Area equals L times W. Great. Any questions so far? Okay. So now what I'm going to say is I have two unknown variables, it's length and width. I want to get it down to one variable. So what I'm going to do is I'm going to solve my constraint equation for one of my variables. The equation I'm going to choose is, let's say, solve for L. So I would say 2L is equal to the number 400 minus 4W. How did I get that? I just subtracted 4W from both sides of my equation. And after 2L equals 400 minus 4W, I just need to divide both sides by 2. We'll get length L equals 200 minus 2W. Now, for the record, I could have also chose to solve for W here. It does not matter for this particular problem because it's pretty straightforward either way. I just chose L at random, and it doesn't matter. Now I can plug in L right here into my objective equation, and I will get the following. Area equals quantity 200 minus 2W times W. Before I take the derivative of this, which is the next step, I do want to distribute the W to both terms. So I'll get area equals 200W minus 2W squared. Okay, great. Now I'm going to take the derivative. And we'll see why I'm taking the derivative in a second, but the next step is the derivative. A prime, this is a pretty simple derivative. It's 200 minus 4W, just a series of power rules. And now I want to set this equal to 0. I'm setting it equal to 0 because I want to solve for the critical points. And critical points, if you remember, are where the first derivative equals 0. Now, what's so special about critical points? That's a rhetorical question. You don't have to answer it. But what's so special about critical points is the fact that that's where my maximums and my minimums occur in the problem. And if I want to find the maximum area, then I need to find the critical points of this equation. It's going to be setting this equal to 0. So I add 4W to both sides. 200 equals 4W. Divide both sides by 4. We'll get a width W equals 50. Now, is width equals 50? Is that the max width? Probably, but we haven't proved it yet. You need to now plug it into a number line and use the first derivative test to actually test out our answer and solve. So for this one, I know 50 is my critical point that goes on the number line. I'm then going to plug in points into my first derivative of area, which we said A prime was equal to 200 minus 4W. So I'm going to plug in points into that equation. If I plug in easy numbers, like if I plug in 0 first, and I say 200 minus 4 times 0, that will obviously be positive. So positive on the left side. And if I plug in a number like 100, 200 minus 4 times 100, that would give me negative 200, which is negative. So after plugging in points, figuring out where it's pluses and minuses, then I ask myself, okay, is this going to be a maximum or a minimum? And the answer is going to be a maximum because the sign changes from positive to negative. So it's a max at x equals 50. Then it's always at this point where students ask themselves, okay, but is this the final answer to the question? And the answer to that is, what did the question even ask? So I scroll up to what the question asked. What should my dimensions be to maximize the area? If I want to find the maximum area, then I need to find, well, actually, no, it's asking for the dimensions. So it's not asking for the area itself, it's asking for the dimensions. So I found x, I'm sorry, why did I say x? It's w. So I found w. Now I just need to find the length. And to do that, I plug back into the constraint, not the objective. I solve back into the constraint. And the constraint we said right here, the L value is just equal to 200 minus 2W. L is going to equal 200 minus 2 times 50. And we're going to get L equals 100. So the length is 100 feet. The width is 50 feet. And there's my answer. I am done. If the question asked me instead, what is the maximum area? They actually want to know the area. Okay, then I'd plug in L and W back into my objective equation and find the area. But for this one, we're done. So that's it. Any questions on this one?
I'm good for this one.
Okay,
I'm good.
thank you. And for the next one, we're going to look at one more optimization problem, and then we'll move on to exponential and the other topic. This example is going to be one of the harder ones for two reasons. Number one, it's the cylinder, which is just harder in general than a rectangle. And number two, it's going to be harder because I'm going to introduce cost. And cost is always kind of a trickier concept, but we'll do it together. We'll handle it. So for this one, I want to maximize the, well, really the cost. I want to find the minimum cost to, let's say, paint this cylinder. This is in the shape of a cylinder. And I'm going to paint the sides of the cylinder blue. If you don't have colored pencils like me, you can just say blue, a little arrow next to it. And then I'm going to say the top and the bottom of the cylinder are going to be red. So in other words, the body of the cylinder is one color, the top and bottom are another color. Now, as we all know, blue paint is more expensive than red paint. As a matter of fact, blue paint costs 60 cents per square foot, and red paint costs only 25 cents per square foot. We all know that. We all go to Home Depot on a regular basis. And so now the question becomes, what is the minimum cost in order to paint this cylinder the way I want it to? But I do have a constraint. I want there to be at least 600 feet squared of, I'm sorry, not squared, cubed, at least 600 feet cubed of volume. And I want to know what is the minimum cost. So again, even though this problem is significantly more challenging for several reasons, the process stays the same, which is the nice thing about most topics in calculus. The process stays the same. What's going to change is what the objective and the constraint equations are. So again, I'm going to ask myself, what's the objective and what's the constraint? I'm going to start with the constraint because, again, I think it's easier to do so. So the constraint's going to be my 600 feet cubed because that's the number they give me. The constraint's always the number. And I know it's volume because they tell me it's volume. So volume equals 600, and now I need to remember what the volume of a cylinder is. I'll be honest, I don't know if your professor will give you the formula for a cylinder on the quiz or the test. Obviously, if you think they will give it to you, you don't have to memorize it. But if you're unsure and you want to be on the safe side, you can memorize this equation. Volume of a cylinder is equal to pi r squared times the height. Let me give some dimensions here. There's r, there's h. You probably already knew that, but I'm just going to write it on the diagram because why not? And the other thing worth knowing is the reason it is pi r squared h is because I like to think of volume of a cylinder as a bunch of circles stacked on top of each other for a height h. So for that reason, it's pi r squared, which is the area of a circle, times a height h. That's how I logically think of it. So now we have our constraint equation. Great. Now our objective is going to be significantly harder. So first of all, it is surface area because surface area goes hand in hand with volume, but it's also surface area because I want to find the cost. And the cost is going to be directly related to the surface area of the object, how much area we're painting. So first, before I find the cost, I am going to find the surface area equation. I can call it SA or just S, I don't really care. But I know that the surface area of equation of a cylinder, again, I memorize it, you don't have to, but I know it's a bunch of circles, circumference of circles stacked on top of each other. That's the blue region. Circumference of a circle is 2 pi r, and I'm saying times h because it's stacked h high. And then I need to add the top and bottom of the cylinder, which is going to be pi r squared times 2 because there's a top and a bottom. Now, one more time, just to kind of color code this. This is the body of my cylinder. This is the top and bottom of my cylinder. And that's going to be important when I factor in the cost. Okay, I'll give you guys a second to catch up. But more importantly, for me to drink water. Okay. For the next part, I need to say, what's the cost of this thing? C equals. And if I think about it, whenever I have a cost problem, all I need to do is multiply the cost by the formula, or at least the part of the formula that's affected. What do I mean by that? If the body, the blue, is 60 cents per square feet, then I'm multiplying my body equation by 0.6. 0.6 the cost times 2 pi r h. Any questions with that? Okay. Plus 2 pi r squared times its price, which is going to be 0.25, because that's the cost of the paint for the top and the bottom. And there's my cost equation. There's my cost equation. I can simplify this if I want. I'm going to get C equals 1.2 pi RH plus 0.5 pi r squared. And now I'm ready for the next step, which is exactly the same as the last problem, and it's not take the derivative yet. The reason I can't take the derivative right now is because I have two variables. I have r and I have h. So before I solve for r or h, I am going to have to solve my constraint equation for one of my variables. I can either solve for r squared or I can solve for h. I'm going to solve for h because I hate solving for r squared. So I'm going to solve for h. H is equal to 600 divided by pi r squared. It means I don't have to take the square root of both sides, so that's nice. So height equals 600 over pi r squared. I can now plug that into my equation for h right here. It's 600 over pi r squared. So I'm going to say cost equals, in the numerator, well, I guess I'll just write it out like this first. 1.2 times pi times r times the quantity, 600 divided by pi r squared. And then plus 0.5 pi r squared. Now, again, before I take this derivative, I am going to have to try and simplify this. A lot of my students have trouble figuring out how to reduce, specifically, like the right side's fine, but it's this term that really needs reducing. So just remember, the 1.2 pi r is technically 1.2 pi r divided by 1. In other words, I can cancel out anything in the numerator and denominator I see here. For instance, I see that the pi cancels right there, and I also see the radius cancels right there, leaving me with 1.2 times 600 divided by r. So cost equals 1.2 times 600. I'm just going to plug that in my calculator. 1.2 times 600. We get 720. So 720 divided by r, that's it for the left side. And then plus 0.5 pi r squared. Any questions so far? Okay, great. I would say the hard part's probably over already. But one more thing before we take this derivative, which is the next step, of course. I don't know the derivative of 720 over r unless I first rewrite it as 720 times r to the negative first power. Don't forget that trick that allows us to take derivatives of functions in the denominator, and then plus 0.5 pi r squared. Okay, now I can take this derivative. So c prime is equal to, multiply the negative 1 out in front, we get negative 720 times r, now to this negative second power, plus derivative of this, 0.5 times 2 would just be 1 pi r now to the first. Now I'm going to set this equal to 0. By the way, whenever I set something equal to 0, and I have some nonsense like this, like r to the negative second power, okay, now I'm going to write it back in the denominator. I'm going to put r back in the denominator because I don't want to solve for r to the negative second power. That's just confusing. So I'm going to rewrite this as negative 720 divided by r squared plus pi r equals 0. Hopefully this makes sense. Now, this is a fun part. There are technically 3 correct ways to solve for r. I'm just going to do the one that's the most straightforward, in my opinion, and you can do whichever one you like. But I'm going to add 720 over r squared to both sides. Now we have, on the left, just pi r. On the right side, we have 720 divided by r squared. And now if I want to solve for r, I need to multiply both sides by r squared to eliminate that denominator. So on the left, I have pi r cubed. On the right, I now just have 720. I divide both sides by pi. So now r cubed equals 720 over pi. And then I'm going to take the cube root of this whole thing. If you don't know how to take the cube root in your calculator, you can instead raise it to the 1/3 power, which is what I'm going to do. 720 divided by pi, and then that raised to the 1 divided by 3 power. I get a radius of 6.12 feet. Now, is that my minimum radius? I don't know yet. I still need to prove it by using the first derivative test. So on my number line, I have 6.12. The equation again is c prime, which we said was equal to negative 720 over r squared plus pi r. Let me double check that. Negative 720 over r squared plus pi r. Okay, great. Now I need to plug in a number less than 6.12 for r. I can't choose 0 this time, actually, because if I plug in 0, I get a 0 in my denominator. But I can choose 1. So if I plug in 1 for r, I mean, I just see negative 720 plus pi times 1. Yeah, that's definitely going to be negative. And then I plug in a number greater than 6.12, like 10. I'm hoping this is positive, but let me just double check. Negative 720 divided by 10 squared, which is 100, plus pi times 10. Yep, a positive number, positive 24. But all I care about is the positive. So after I plug in the 2 points, I get the sign change. It's negative to positive. It means I do have my minimum, my min at r equals 6.12. This is great. Now I still need to find the value for h. Luckily, back in my constraint equation, I had an equation to solve for h. I'm going to scroll up. And I saw back in my constraint equation, h the height equals 600 divided by pi r squared. So I'm gonna plug in right now. H equals 600 divided by pi times 6.12 squared, the radius. And so now height equals 600 divided by pi divided by 6.12 squared, and we get a value of height equals 5.1 feet. We have our dimensions height and radius. Any questions so far? We're almost done. Just one step left, and that is to actually find out what the cost is. Remember, once you find the dimensions, that's not necessarily the final answer. Always read the question. So in this case, I want to know what is the minimum cost. For that reason, I'm plugging into my original cost equation, which I said was, I got it actually down to here. 720 divided by, oh, well, you can also plug in r, but I'm going to do the one with r and h, because why not? So 1.2 times pi times r times h plus 0.5 pi r squared. Technically, you can also plug into this equation. You actually don't even need to solve for h, but I always like to solve for h because it's good practice. So 1.2 cost equals 1.2 pi r squared h, or sorry, just rh, plus 0.5 pi r squared. Let me double check that. Okay, yes, this is the correct equation for cost. Now I'm going to plug in for r equals 6.12 and h equals 5.1. Let's plug it in my calculator and see what I get, and it will be the final answer. Times 6.12 times 5.1 plus 0.5 times pi times radius squared, so 6.12 squared. And you get a final answer that the cost is going to equal $176. And 3 sig figs is good. Now, are you guys allowed a calculator on your quizzes and tests?
Yes, just not
Okay.
a graphing calculator.
Okay, great. Yeah, so this is all, I think, fair game. Okay, so any questions on optimization? That's pretty much it, because I can't think of many examples harder than this one.
I think I'm good. You explained it pretty well.
Okay, great. Thank you. What can I say? I'm a master explainer. That's what I do for a living. Okay, enough showboating. For the rest of the time, I'm going to talk about exponential and logarithmic functions. So with exponential functions, first I want to talk about the three main properties of exponential functions. If I have, let's say, 2 to the x, or I'll say this actually. I'll say x squared times x cubed. I know this equals x to the 2 plus 3 power, which is x to the 5th. In other words, multiplication in the bases becomes addition in the exponents. Now, similarly, if I have division, if I have x squared divided by x cubed, whenever I have some division, it's going to become subtraction. So x to the second minus third power. That would leave me with x to the negative first power. If I wanted to, I could even rewrite that as 1 over x, if I felt so inclined to do so. I don't think it matters too much. Both would be accepted. And then the third property I want to say is if we have x squared and all of that is cubed, when you have a power raised to a power, like here, you multiply the exponents, so it's x to the 2 times 3 power, you end up getting x to the 6th. These are the three properties you absolutely need to know, and from there you can pretty much use any of the other properties to solve the questions that we want to. So first let's look at this problem just to practice with our manipulation, our exponential manipulation. Let's say I have x squared, there's going to be a fraction here, x squared times y times w to the 4th divided by y squared, and I'm going to multiply that by w times y divided by, let's say, x cubed. And I want to know what the result is. I want to put this in the most simplified form as possible. So the first thing I say is I want to group the like terms together. In other words, I look at my x's, I would have x squared divided by x cubed. I want to look at my y's. So with the y's, I have in the numerator y times y. In the denominator, I have a y squared. And then for the w's, I just have w to the 4th times w to the 1st. There is no denominator there. And the other thing I want to say is from here, I think it's pretty straightforward. If you want to kind of jump ahead and just cancel out or whatever, you can do that, of course. But I'm going to kind of do it the longer, more straightforward way, and that is the following. For the x's, I'm going to say it's x to the 2 minus 3 power because it's division, and then times. There's no pluses or minuses. Notice there's no pluses or minuses in like the actual like numbers here. Like all this is multiplication, which is why I'm allowed to do all the manipulation I'm doing right now. So it's x to the 2 minus 3 power times the y terms. It's going to be y to the 1st plus another 1, that's the numerator, and then minus 2 for the denominator. And you end up getting y to the 0 power, which is just 1. And the reason that makes sense is because really the y squareds cancel here. All those y's cancel. But if you don't see that, you can use the exponents, and you get the same answer. And then times w to the 4 plus 1 power. We're going to get a final answer of x to the negative 1st times y to the 0, which again is 1, times w to the 5th. This would be a good final answer. If I wanted to, I could also rewrite it as w to the 5th over x. Because again, x to the negative 1st power just means put it in the denominator. Any questions on that one? Okay. So now where it really starts to get tricky with exponential functions is when we actually start solving them with equations. What do I mean by that? Let's look at an easy one first, then we'll look at a more complicated one. Let's say I have 5 to the x plus 4 is equal to 5 to the 2x minus 10 power. One thing you need to know about exponential functions, whenever the bases are equal, like here, the 5 and the 5, you can set the exponents equal to each other. In other words, I get x plus 4 is equal to 2x minus 10, and now I want to solve for x. So I'll subtract x from both sides, add 10 to both sides. We end up getting on the left 14, on the right just x. X equals 14 is my final answer. And just so you know, that means if I plug in 14 here for the x for both terms, I get the same thing. And just to prove it real quick, I would say to myself 5 to the 14 plus 4 power, that's 5 to the 18th power, is equal to 5 to the 2 times x. So 2 times 14 is 28. 28 minus 10 equals 18. 5 to the 18 equals 5 to the 18. This is the reason why we're allowed to use this strategy, because the exponents are equal to each other. So now that's, I would say, the easy case. The difficult case is when I give you different values for the bases. For instance, let's say I have 3 to the x plus 1 is equal to 9 raised to the x minus 4 power. Notice the bases are different this time. I cannot just set them equal to each other. However, I do notice that 3 squared is equal to 9. In other words, they do have a relationship to each other, which means I can manipulate my bases in a way to get me in one of my bases. Ultimately, what I have to do is I have to choose the base I want to use. I can either choose base 3 or base 9. Let me tell you, I always want to use the lowest base. Use lowest base. In this case, the lowest base is 3. So I'm not going to touch the left side, 3 to the x plus 1. That's great. The right side, I'm going to rewrite 9 as 3 squared, and now 3 squared is raised to the x minus 4 power. What I'm doing is not illegal. It is very legal. It is good. I just wrote 9 as 3 squared, and now I have my power raised to a power, which means I can rewrite my right side as 3 raised to the 2x minus 8 power. In other words, I multiplied 2 by x minus 4. Again, I can do that because of my power raised to a power rule. On the left side, I still have 3 to the x plus 1 power, and now I have the same base. I can solve for x pretty easily. X plus 1 equals 2x minus 8. Same thing as before, subtract x from both sides, add 8 from both sides. We get 9 on the left equals just x on the right. There's my answer for that one. Any questions so far? Okay, so now the last question we're going to look at for same type of question, but I want to look at one where I have a negative power, or really just a reciprocal. What do I mean by that? Let's say on the left, I have 1 over 25. This is raised to the 4x plus 2 power. On the right side, I have just 5, and that will be raised to the x squared power. Now, one thing I do need to be careful of whenever I deal with x squared, I am also just kind of making up numbers on the spot as I go. There's a very good chance where I mess this up and we have to end up using quadratic formula, but that's our future problems. That's not the present problem. So what do I do to get my lowest base? And definitely I want to get the base 5 because that's the lowest base. Before I get the 5, I notice that I have 1 over some number. The first thing I'm going to do is I'm going to say, okay, well, I know that 1 over 25 is equal to 25 to the negative first power. That's raised to the 4x plus 2 equals 5 to the x squared power. So on the left, I'm just going to do this first. 25 raised to the multiply negative 1 by both terms. So it's negative 4x minus 2. Did I lose anybody with that? Equals 5 to the x squared power. Now I can get my common base, which is again the 5 squared. So I'm going to rewrite that now as 5 squared raised to the negative 4x minus 2 power. And again, I can multiply the bases together. So now 5 raised to the negative 8x minus 4 power is equal to 5 to the x squared power. Now I can set these two functions equal to each other. So negative 8x minus 4 equals x squared. Now I need to solve for x. The other reason I want to look at this kind of problem is because a lot of you out there don't actually know. I say a lot of you out there. There's only 3 of you, which is kind of funny. But a lot of you out there don't know how to solve this equation because it's a quadratic. A quadratic function does not always mean quadratic formula. but again, it's quadratic because it's x squared. That's what quadratic means. How I solve functions with x squared in them, I need to set the function equal to 0. I need to. So I like having the leading power positive. So I'm going to say 0 equals x squared plus 8x plus 4. In other words, I multiplied both sides by, not multiplied, I added 8x plus 4 to both sides. And now what I want to say is, okay, well, can I factor this? If I think of the factors of 4, it's 1 and 4 and 2 and 2. And I'll tell you, regardless of what numbers I choose, since everything's positive, there's no way I'm going to get a number that adds up to 8 just out of 1 and 4 and 2 and 2. I am going to need quadratic formula for this problem. If you remember, quadratic formula said x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here's what I'm going to say. I'm going to say x equals negative 8 plus or minus the square root of 8 squared, which is 64, minus 4 times 1 times 4, all divided by 2 times a is also 1. I would get x equals negative 8 plus or minus 64 minus 16 is 48. I don't know what the square root of 48 is, but it's close to 7. 6.9. So plus or minus 6.9 divided by 2. And so let's see what answers I get for x. Negative 8 plus 6.9 divided by 2. One answer we get is x equals negative 0.55. The other answer is when I subtract 6.9 from both sides divided by 2. I also get x equals negative 7.45 as my other solution. And there are my answers for this one. And that's how we solve quadratic functions. Any questions for that one? Again, I don't want to gloss over this. I want to really point out what we had to manipulate this 1 over 25 to. First, I said negative first power because that brought it back up to the numerator. Then I did power to a power multiplied by negative 1. Then I wrote it as 25 as 5 squared because I always want to get the lowest number as my power. Any questions? Okay. Now, the last thing I want to talk about today is logarithmic functions. Luckily, logarithmic functions are not too bad. What we're looking at here is the following properties. If I have the log of x times y, that would equal the log of x plus the log of y. In other words, multiplication inside the logarithm becomes addition outside the logarithm. Similarly, if I have the log of x divided by y, that's going to equal the log of x minus log of y. So division becomes subtraction. And then finally, if I have that power thing, this time I'm going to say if I have log of x cubed. Whenever I have the whole thing raised to a power, in this case the whole thing's x. Whenever I have x to the third power, I can rewrite that by moving the 3 out in front. This is going to equal 3 log of just x now. Notice this is not a derivative. This is like the original function. I'm just rewriting it. I'm simplifying it. But I can do that. That's a property of logarithms. And by the way, this is all true no matter what the base is. In this case, it's log of whatever. It's true if you have natural log. It's true if you have log base 2. These properties hold no matter what your base is, which is pretty cool. So now for the last few problems, we're going to just solve a few more equations, simplify, and then we'll call it quits there. I think that'll be a good use of our time. So for this first one here, let's say I have log of numerator 4x times x cubed plus 1, denominator 3x minus 6, close parenthesis. And I want to see how I would expand this. So the first thing I would say is I have two things in the numerator. I've got 4x and I've got the x cubed plus 1, and then I have one thing in the denominator. So immediately I'm going to say this. This is equal to the log of 4x plus log of x cubed plus 1, and then minus log of 3x minus 6. And again, this is true because multiplication became addition and division became subtraction. Now I look at this and I ask myself, does this simplify anymore? I want you guys to answer this in your heads. Don't say it out loud. But this cubed right here, can I write that 3 out in front of the logarithm? Yes or no? Again, answer it in your head. Can that 3 be moved out in front of the logarithm? The answer is no, it cannot. And the reason is because the whole thing needs to be cubed. Notice the +1 here means that it does not work. So then the question becomes, is there anything I can do to simplify this? I would say there's one more thing. And it's kind of sneaky, but you can do this. See how log of 4x is really 4 times x? That means I can also, if I wanted to, rewrite this as log of 4 plus log of x plus the other stuff, plus log of x cubed plus 1 minus log of 3x minus 6. Again, that's more of an optional thing. And so now there's just one more thing I want to talk about, and that is, actually, just real quick, have you guys learned about derivatives of exponential and logarithmic functions yet?
No.
Okay, that'll probably be next. So the last thing I want to say is, how would you solve an equation with log in it? Let's say I have the natural log of 5x plus 4 equals 1. How would I solve for x here? So whenever I have a natural log, just like anything else in math, like if, for instance, I had 2x equals 4, the way I solve equations in math is I have to do the opposite operation to get x alone. The opposite operation of multiplication is division. What's the opposite operation of the natural log? It's base of whatever the base of your logarithm is. In other words, the base of natural log is really log base e, so I'm going to take base e of both sides. And what happens is the e and the natural log essentially cancel out. I am now left with, on the left side, 5x plus 4. On the right side, I now have e to the first power, which is really just e. I don't have to write the first power. But now to solve for x, I would say 5x equals e minus 4, subtract 4 from both sides, then divide by 5. We'll get x equals e minus 4 divided by 5. That's how I solve for logarithmic equations. Let's look at just one more. Let's say I have log base 2 of x cubed is equal to 0. So for this one, I would say, what's the opposite operation of log base 2? It's take the base 2 of the power, okay? So now I have 2 and log base 2 cancel out. I'm left with x cubed is equal to 2 to the 0 power, which is actually just 1, because anything to the 0 power is 1. And now I just take the cube root of both sides, and we get x equals positive 1. If you're thinking that, hey, Dan, shouldn't it be plus or minus 1? I would say no. Check yourself, because whenever you take cube roots, it's not plus or minus, it's just the positive. The only time you take plus or minus is if it's an even root, like the square root, for instance. That would be plus or minus. But since it's cube root here, it's just positive. It's x equals 1. Final answer. Any questions for this one?